A very warm welcome to each of the students who have joined us for the Digital Signal Processing course EE3101 as part of the BS Electronic Systems program. Welcome once again, and we hope that you will enjoy this course very much. Let me start with a brief introduction to the course. Today's lecture we will cover the overview of the course and a brief introduction, and also wanted to have an opportunity to introduce myself. I'm Professor David Koilpllai, who will be teaching this course, and we have our instructor, Mr. Tony Varkey, who will be interacting with you on a regular basis to handle all of the tutorial sessions. Again, the two of us are always available on email. You can note down this email IDs, and we will be happy to respond to any questions that you may have. Let me jump right into the course and tell you a little bit about what the course will contain. First and foremost, I want to congratulate you on successfully completing the Signals and Systems course, which is a prerequisite for this course. And in the Signals and Systems course, you would have studied a lot about the properties of signals, linear time invariant systems, but you would have studied them all in the continuous time. Now, DSP is the course where you go from the continuous time representation of signals and systems to the discrete time. So, the focus of this course is going to be on our ability to represent the signals in discrete time. So, if you were to say it in a nutshell, DSP is the tool that enables us to take signals and systems from the continuous time domain into a digital domain where we can then use the computers for our study and for tools. So, it becomes a very powerful tool. Now, what all can you do with the DSP? As I said, DSP deals with the digital representation of signals. You can talk about the compression of signals, of digital signals. That is one of the applications. We can talk about the communications of signals. You can talk about transmission of a signal, storage of a signal, retrieval of a signal. All of these are possible. Now, in addition to that, we can also talk about the encryption of a signal and the decryption of a signal. So many things are possible to us in the discrete time domain, which were not possible to us in the continuous time domain. So what I would say is, in a nutshell, DSP opens the door to a number of very interesting applications. And just to take one as an example, the cell phone. The cell phone that we use almost on a daily basis. This is something that we will find that has got a tremendous amount of signal processing that is going on in the cell phone. So let's take a quick look, just as a motivation for why we want to study this course. I've collected for you some phones which I have worked with in the last 30 years as I've been in the field of wireless communications, and have looked at the evolution of the cell phones. So starting way back in 1989, we had certain phones. Some of these phones you would not have even have seen, but these were the early phones. But the interesting thing to note that starting from this was part of the second generation of the cellular system. And even in the second generation, we had what was referred to as digitized voice. So voice was not carried as an analog signal, but it was carried in its digital representation. So we see that the use of DSP came into the cell phones right in a very, very early stage. And of course, we were also handling data in the form of SMS. So even in 2G, we were already using DSP. Then move the clock forward, move it into the 3G domain, and eventually into the 4G, where you started to have phones with color displays and number of applications. So look at on the right hand side. You have what was early in the 2G era. And then as we moved over to the 4G, we already saw DSP applications in the 2G era, but as we moved into the 4G, we see many, many applications. And one of the things that we want to do is to learn the fundamentals so that you can then appreciate and look at all of these applications and work with them. So, as a particular example within today's cell phone, if you were to look at where signal processing is coming into play, take the latest iPhone for example. It has one of the most sophisticated cameras among cell phones. If you were to look at the specifications, it has a 48 megapixel main camera, it has ultra wide mode, it has a telephoto mode, it has got a 10x optical zoom. And now just imagine what you have is just a simple lens. Now, where are all these features coming from? All these features are coming because there is signal processing running in the background. The basic image is captured and then a lot of the enhancements are being done. So, you see how much impact the cell phone technology can have. Now, all of this is made possible because the cell phone has got a very nice display. Now, some of us may not, we use the display but may not understand how much signal processing is going on. It is not actually just a single layer on which you touch. It actually is made up of 7 layers inside that, and it has got a grid of wires and pressure sensitive layers. Now, when you touch with one finger, the phone has to recognize which point on the screen you have touched. Now, extend it to the 2 touch finger. Basically, many of your applications require you to touch with 2 fingers. Now, you have to detect where those 2 pressure points are and then detect what exactly you are doing. Are you expanding the screen? Are you selecting something? So, this is a tremendous amount of signal processing that's happening inside of the display, and therefore, not only the camera, the display, a lot of things where signal processing is happening, and several other applications I would say are of interest, and we can look at it. So anytime you are working with images, anytime you're working with videos, anytime you're dealing with voice, you can assume that there's a lot of signal processing that is happening in the background. Now, let us look at the cellular system itself. Where all do we find signal processing coming into the cellular signal? First, where it comes is in the source coding. We speak, it's an analog signal, it is then processed into a digitized voice. Then comes the aspect of modulating the signal. Then the pulse shaping so that the spectrum is compact. All of that is part of signal processing. The D to A conversion is part of signal processing. Then move over to the receiver side. Starts with the receive filter, we call it the match filter. Then after that we have the analog to digital conversion. From that point on, all the discrete time processing is happening. Now, there is a tremendous amount of signal processing that happens in the down conversion process and in the in the receiver process. Okay, so I want you to, some of you may be familiar. What are some of the applications that are happening on the receiver side? One of the main applications of signal processing is to synchronize the receiver to the transmitter. So, synchronization is a DSP function. There are 2 types of synchronizations. We have frequency synchronization and we have time synchronization. Both of these are done using signal processing algorithms. Then you may have to do an equalization step in order for you to retrieve the signal and then eventually detect the signal. So basically there's a number of signal processing operations that are happening, and then eventually the source decoding, converting it back into a speech signal or to a video signal. All of these are signal processing. So you see that signal processing plays an important role, has got a number of functions where it has a significant impact. So let us now look at where else do we find signal processing. Now, we said that there is signal processing in the applications, that is in the camera, in the touch screen. We talked about the what's happening inside of the phone. Now, in the transmission process that is involved in a cellular system. So, for example, in the 4th generation system, the modulation method, we said that there is a signal processing there. The way it is done is using a method called orthogonal frequency division multiplexing. OFDM is the acronym that is used for the modulation method. This is based on the FFT. What is FFT? The fast Fourier transform. And where does that come from? Comes from signal processing. So at the heart of a 4th generation system or a 5th generation system, you will find that the modulation method is OFDM, which is based on the FFT. Now, if you move to saying where else can I find we use multiple antennas in a 4G system. We use it for beamforming, we use it for spatial multiplexing, we use it for multi-layer transmission. Now, all of these, along with the diversity transmission, all four of these methods of using smart antennas are all involving signal processing of different types. So again, this is a very rich subject or area where we will find tremendous amounts of application, and therefore I believe gives us a strong motivation for us to study. Now, coming down to the course that we are going to be looking at. Of course, there's signal processing everywhere, all around us. But what about EE3101? Okay, the course that we are going to be looking at. Okay, it is a very practical course. We're going to learn theory, but we're also going to learn how to use it in the form of simulation, computer simulations, computer exercises, and also problem-solving exercises. So basically, it's a very practical course, a hands-on course where you will solve a number of exercises and learn the concepts through practice. As we said that there are a number of applications of DSP. You will discover that as you study this subject, there will be more and more areas where you will find that DSP is being used. Of course, we mentioned that in all forms of communication, DSP is being used. Today, one of the hot areas in engineering is machine learning. Every branch of engineering is saying we can use machine learning, we can use deep learning in our technology. Now, the basis, the foundation of machine learning comes from signal processing. So you can see that DSP is going to be a very important part in the future as well. So we can safely say that DSP is there in every branch of engineering. Now it has moved into medicine. If you look at ultrasound, you look at MRI, all of those also are based on signal processing. Now, not only engineering and medicine, you can also look at finance, operation research. They are also using signal processing principles. So what we learn in this course will give you a good foundation for you to study and apply these concepts in not only in the context of signal processing, but also in the future for other subjects as well. So before we begin, I thought it would be good to give a brief introduction about myself. I'm a professor at IIT Madras. I've been here for the last 22 years. Prior to joining IIT Madras, I was in the industry working with cell phones, and that's why many of my examples will be of cell phones and cellular technology. Was part of a company called Ericsson, and there we were developing the 3G cell phone systems. So again, since joining IIT Madras, I've been focusing on signal processing and wireless communications as my main areas, and therefore very happy to have this opportunity to interact with you and to also study the subject of signal processing together with you. So moving on to the course 3101, it is one of the what we would call a foundational courses as you work towards your degree, the Bachelor of Science in Electronic Systems. This is a course which would be considered a 5-credit course where there will be weekly assignments and we will have a number of lectures. Mr. Tony will be giving you a detailed instructions on how the course will be structured and how the evaluation will be done, but at a top level. After 4 weeks, we will have a quiz 1, we call it quiz 1, and then after 4 weeks, quiz 2, and then eventually end semester exams. But more than the quizzes, the focus should be on the weekly assignments, because that is where we believe all of the concepts will be learned and applied, and those will strengthen. And once you have done the weekly assignments, the quizzes would be relatively not as difficult, and you will be able to do well. And as you are probably aware, since you have already come into the 3rd year in the program, the way the quizzes will be conducted, the way the exam will be conducted, all of it will be exactly as per the BSES program. And if you have any doubts, we will be happy to clarify in terms of specific questions that you have. Now, this is a course which requires signals and systems as a prerequisite. So, in case you have not completed the 2101, you will have to discuss with us and with the course coordinator to see if this is a course that whether you can take the DSP course at this time. what I would like to do is encourage you to look at the syllabus. Syllabus is presented for you, will be presented for you in the on the online website. But just to give you a feel for what we will be starting with, let me focus on week 1 and 2. The first 2 weeks of our study will be a review of whatever you have studied in signals and systems, but not in the continuous time, but moving over to the discrete time. So basically, concepts that you have studied, we will review them, but also move quickly into the discrete time domain. The basic operations that you had studied on continuous time signals, we will now translate it into discrete time. The different types of signals, sinusoids, complex exponentials, the unit step function, impulse function, all of those things, we have their discrete time counterparts. So we will talk about that. Then once we finish talking about signals, we will move over to discrete time systems, and we'll talk about linearity, time invariance, what is the, how do we characterize linear and time invariant systems, how do we define memory, causality and stability of these systems. So again, most of these concepts would be familiar to you. Where I would emphasize on is the translation from the continuous time to the discrete time, so that you will have a complete framework in terms of discrete time. Once we move past the week 1 and 2, we will then look at we will, by the way, introduce sampling right in the first week itself. Subsequently, we will be spending a substantial amount of time developing the theory of sampling and the theory of reconstruction. These are very important concepts for us, because this is what enables us to take any continuous time signal and then move it into the discrete time domain and then process it using the tools that are available to us. Now, as you are probably aware, that the discrete time domain has got a vast array of tools that are available to us. So in terms of computational tools, algorithms like the fast Fourier transform, so we have tremendous advantages of moving into the discrete time, and that process is possible once we have a good understanding of sampling and reconstruction. Now, if I were to ask you what was one of the most important tools you studied in signals and systems, I'm sure you would say the Fourier transform. Fourier transform is the foundation for us to go from the time domain to the frequency domain, correct? And in the discrete time, we also have a Fourier transform, but it will be the discrete time Fourier transform, a different transform, but that operates on discrete time signals. We call it the DTFT. And just like you would have derived the properties of the Fourier transform, we will then derive the properties of the DTFT. We'll talk about the inverse discrete time Fourier transform, and this gives us the first window for us to move from the time domain or the discrete time domain into the frequency domain. And of course, there are relationships between the continuous time Fourier transform and the discrete time Fourier transform. All of those relationships we will develop as part of a very comprehensive mathematical framework. There are two textbooks that we will be following closely. One is the textbook that is prescribed as part of the syllabus, Oppenheim Schaefer Discrete Time Signal Processing, again a book that's readily available. In addition, there is a book by Tarun Rawat, which is also the same title, Digital Signal Processing. And this book has a good set of exercises. And so basically, for the theory, we will look at both. For the exercises, we will be looking at the book by Rawat. And again, this will be a very useful combination of two books, which will give us a good foundation for the study of signal processing. So with that introduction, we are ready to begin the topics of week 1, and again, if there are any doubts or questions regarding the syllabus or the grading or that, please feel free to email Mr. Tony or myself, and we will be happy to respond, and we of course always available to guide you and assist you.